3, 2, 1, liftoff. 3 numbers and 2 words that often propel humankind beyond the world as we know it. In 2018, there was 114 space launches. Some of these missions transported satellites into orbit, with others taking brave astronauts to the International Space Station to provide out-of-this-world research. Either way you look at it, though, these missions have an impact on the environment in one way or another. Hazardous waste produced from launch can affect the local ecosystems and even prevent local flora and fauna from thriving. Air exhaust emissions from propellants can lessen air quality and even damage the ozone layer. In addition to the environmental concerns, it costs NASA millions of dollars in propellant alone to launch one rocket into space. Thus, it can be said having a cost-effective and environmentally safe propellant is an expensive concern for NASA engineers and the Earth. Though we've come a long way from using the propellants that put the Apollo 11 team on the moon, scientists and engineers are still looking for a more cost-effective and environmentally safe propellant. And it is through this search that my research comes into play. When aerospace engineers design a novel propellant, they come to chemists like myself to analyze and characterize them. Using powerful analytical techniques, such as mass spectrometry, we are able to probe into the structural characteristics of a propellant and provide general information for these engineers that can provide future discoveries. In addition, through our analysis, we are able to elucidate potential byproducts that are formed during combustion reactions, and based off of general, simple chemical characteristics, determine if a propellant is environmentally safe or not. Our analysis can also evaluate the stability of propellants, and we can look at potentially dangerous functional groups and other chemical characteristics that the engineers don't want present in their propellants. Through our analysis, we can also probe into the mechanisms for the formation and combustion of these propellants. And by looking at the fragments that are formed during these processes, put together the larger puzzle as to how these propellants are actually working. Though we may not be the ones directly synthesizing these safer and more cost-effective propellants, our work is vital for engineers since we provide information on what it is and ultimately how it works. And it is ultimately our goal through our work to keep toxic byproducts from propellants from making their way into the atmosphere and ultimately rocket humanity forward into a future with more cost-effective and ultimately environmentally safe propellants. Thank you.